Hi my dear students, welcome to chemistry question discussion. See, I hope you enjoyed the questions. നന്നായിട്ട് എല്ലാവരും എഴുതിയെന്ന് വിശ്വസിക്കുന്നു. So the first question is 60 gram of a compound on analysis produced 24 gram of carbon, 4 gram of hydrogen and 32 gram oxygen. Empirical formula of the compound is. These are the questions that are frequently asking. How to solve these types of questions? See here, we have been given 60 gram of a compound which on reaction gives 24 gram carbon, 4 gram hydrogen and 32 gram oxygen. See, first of all, find out the ratio between relative number of moles of carbon, hydrogen and oxygen. How can we solve it? 24 by 12 will give relative number of moles of carbon. 4 by 1 give relative number of hydrogen. 32 by 16 will give relative number of oxygen. So carbon is to hydrogen is to oxygen ratio will be 2 is to 4 is to 2. Okay, then the simplest ratio will be 2 by 2. That is, simplest ratio is 1 is to 2 is to 1. And this is the number of that particular atoms in this empirical formula. That is C1H2O1. That is CH2O, and B is the right answer. Moving to next interesting question. 1.5 gram of cadmium chloride contains 0.9 gram of cadmium. The atomic weight of cadmium is. Simple question. As you know that in cadmium chloride out of 1.5 gram, it is given that 0.9 gram is cadmium and the rest will be chlorine. Right. Now, weight of cadmium divided by weight of chlorine is equal to equivalent weight of cadmium divided by equivalent weight of chlorine. We know that this is 9 by 6. Okay, 9 by 6, that is 3 by 2 equals equivalent weight of cadmium divided by equivalent weight of chlorine is 35.5. So I can, when I substitute 35.5, we can easily calculate equivalent weight of cadmium. Equivalent weight of CD equals 3 by 2 into 35.5, and that will be getting as 56.5. Okay, 53 point something, 53.25 around, suppose. Okay. Now this is equivalent mass. In this example, cadmium is present as CD2+. That is, here n factor for cadmium is 2. So in order to get molecular mass or molar mass, multiply the n factor with equivalent mass. So 2 into 53.25 or 106.5 will be the right answer. Next question. The set of quantum numbers that represent the highest energy of an atom is. See, here first of all you want to see n plus L value. Yeah. For finding out the highest energy value, you want to calculate n plus value. See, n plus greater the n plus value, greater will be the energy. In the first case, n plus L value is 4. Here n plus L value is 5. Here this is 3 plus 1, 4. 3 plus 0, 3. So among this, B is right one. If both of them have same n plus L value, then n plus L with the highest n value will be selected as highest one. So second one will be A. We have been asked only the first option, so B is the right option. Moving on. The diagonal partner of element B is. In periodic table, a special type of relationship between the first member of particular the first member of particular group, a certain group with the second member of next higher group is found. This sort of diagonal relation is what is called as diagonal relationship. See, what are them? Lithium, beryllium, boron, carbon, sodium, magnesium, silicon, aluminum, silicon. Here the relations found between lithium and magnesium, beryllium and aluminum, boron and silicon. So these are that anomalous, diagonal pairs. Lithium with magnesium, beryllium with aluminum, boron with silicon. In this question, only boron is given. The right option is silicon. The correct order of lattice enthalpies of the following ionic compounds is, as you have studied that lattice enthalpy is directly proportional to charge and inversely proportional to size. Very, very important point. Keep in mind. Lattice enthalpy is directly proportional to charge and inversely proportional to size. Listen. Now, take all examples. NaCl charge is +1. MgBr2 +2 and -1, +2 -2, +3 -2. From these examples, you can say that the one with the highest positive charge and negative charges present in Al2O3, so that will be having greatest lattice enthalpy. Then the second one, here we have magnesium with the +2 and calcium also with +2, but there is oxygen with the more negative charge, -2. So this will get the second position. So calcium oxide, the second one. Then magnesium bromide, and finally sodium chloride. Where is this option given? Al2O3 is here, the D is the right option. Did you get it? Moving on to the next question. For one molecule of an ideal gas, increasing the temperature from 10 degrees Celsius to 20 degrees Celsius. Another question from states of matter. Listen very carefully. What we are doing is increasing the temperature from 10 degrees Celsius to 20 degrees Celsius. Then what happens to average kinetic energy? What happens to RMS velocity? Okay, we want to find out both these values and compare with the given options. First is average kinetic energy is represented as kinetic energy equals 3/2 kT, isn't it? So I am taking two cases, kinetic energy with the temperature T1, that is 10 degrees Celsius, that is 283 Kelvin, and 20 degrees Celsius as KE2. I am taking these two conditions, KE1 and KE2, equals 3/2 K will be cut off. Then we will be having T1/T2, right? So T1 is 283 and T2 is 293. This will be close to 0.95 or 96, something will be there, right? That is the value. So the increase in kinetic energy is not increasing by 2 times. Okay, the ratio is 0.96. If I take T2/T1, then with just above 1 point something will be the answer. But this is not getting doubled. Therefore, this statement is wrong. Increases the RMS velocity by √2 times. Find out the RMS velocity. What is the equation to find out RMS velocity? RMS velocity, Vrms equals √3RT/m. Okay, I am considering two different cases. Vrms in two cases. RMS with the temperature 1, that is 283, and with the temperature 293. So this will be getting √T1 by √T2. That's again √283 divided by √293. The answer will be close to 0.9 something will be. So that also can say that increase the RMS velocity by √2 time is the wrong one. Then the third option, increases the RMS velocity by 2 times. Never. Increases both the average kinetic energy and RMS velocity, but not significantly. Yeah, that can be said. Increases, but that will not be like 2 times or 4 times like that. A small increment will be there. That can be calculated using this 3/2 kT values. So moving on. So this is the right answer. I hope you understood. Moving on. A process in which the system does not exchange heat with the surrounding is known as, very direct question, pretty simple question. You all mirror this. Moving on to next question. A system absorbs 600 joule of heat. Okay. So Q value is given as 600. Since it absorbs, I am taking it as positive 600 kilojoule. And work equivalent to 300 joule on its surrounding. And working on surrounding, that means it releases its energy as 300. Since it lost energy, it is taken as minus 300 in chemical thermodynamics. In physics, the sign conversion is opposite to that of our chemistry, right? Anyway, in order to find out the change in internal energy, the equation used is delta U equals Q plus W, nothing but 600 plus minus 300. Very direct question. So the answer is first one, which is not example for common, which is not example of common ion effect. What is common ion effect? It is the suppression of dissociation of a weak electrolyte by the addition of a common electrolyte, by the addition of a strong electrolyte containing common ion. That means the molecule or the mixture, the pair of compound must have common ion, then only common ion effect will occur. See, in the first example you can see chlorine is there in both cases, hydrogen is there in both cases. Here, ionization of CH3COOH will result CH3COO minus and H plus, while NaOH will result Na plus plus OH minus. No common ion is found in this example. Okay, so this is the right option. I am giving the first example, Na plus plus Cl minus plus Ag plus plus Cl minus will be there. So there is common ion. In the second case, H2S will be ionized into H plus plus, SH minus plus, H plus plus, Cl minus. Here also it have common ion. And the last example, NH4 plus OH minus, NH4 plus Cl minus. There also ammonium is present as common. So C is the example of this question, answer for this question. Moving on to next question. Permanent hardness of water is due to the presence of, hardness are of two types, temporary hardness and permanent hardness. Hardness is due to the presence of bicarbonate, chloride and sulfates of calcium or magnesium. This bicarbonate ion hardness can be removed by heating. The hardness due to bicarbonate ion is called as temporary hardness. While hardness due to chloride and sulfate SO4 minus is called as permanent hardness. So the answer is, this is not chloride and sulfate of sodium and potassium nahi. Chloride and sulfates of calcium and magnesium is the right answer. Moving to next question. Washing soda among the following is sodium carbonate, decahydrate is washing soda. Don't get confused. All the options given are sodium carbonate, but washing soda is popular as formula Na2CO3 Next question. For alkali metals, which one of the following trend is found to be incorrect? See, hydration energy given as the correct order, because down the group atomic size increases. Consequently, effective nuclear charge on outer shell will not be that much high. Or down the group, since atomic size increases, the charge to radius ratio will be less. Therefore, it cannot associate with more number of water molecule. So the first one will be having greater charge to radius ratio, and that can accumulate, that can have more envelope like water molecule. That is what is called as hydration. So lithium will be hydrated in larger extent. So this option given is right option. Ionization energy also down the group, with the increase in atomic size, ionization enthalpy decreases. So the option given is also right one. Density, density has some problem. Density in general, we can say that density increases down the group because of increase in mass, while there is a great difference in the volume of atomic volume of sodium and potassium. Consequently, density of sodium is just greater than potassium. So the right density order is lithium, potassium, sodium and rubidium. This is the right option. So this is wrong. Therefore, our answer is C. Okay, atomic size down the group increases. So the statement 4 is also right one. Are you clear, my dear students? Moving on to next question. The IUPAC name of the given compound is, since the molecule contains functional group, that is priority functional group, we should start numbering from that carbon. First carbon, second, third. This is a cyclohexane molecule having OH group. Therefore, this is cyclohexanol. It have 2 methyl branches on third carbon. So, the name must be 3,3 dimethyl cyclohexane 1-ol. 3,3 dimethyl cyclohexane 1-ol or 1 cyclohexanol. The best answer is actually cyclohexane 1-ol, but this is also accepted. So, this is the right option. C, which will exhibit geometrical isomerism. See, what is the condition for showing geometrical isomerism? Either the molecule should have a ring. From this example, you can see that there is no ring inside this. Everything is showing as alkene or alkane. So, among alkene, the condition to show geometrical isomerism are the molecule should have different group on this stereocarbon or multiple bonded carbon. The 2 atoms or groups attached on this particular carbon must be different. These 2 must be different. And here also these 2 must be different. These 2 must be different. It is not mandatory to be differ from here. This group can be repeated there, no problem. This group over varam, no problem. But X and X cannot be. A and A cannot be. These 2 group must be different. These 2 group must be different. The same group can be or can be present or it cannot be. That means a group vannalum vera group vannalum onnum prashanilla. Idu rendum vyatyasamayirunna madi. That's all. Okay. So check it out with each example. 3-phenyl 1-butene. So I am writing 1-butene like this. 1-butene and 3-phenyl. See, here we have a phenyl branch. Now this molecule is not satisfying this equation because it contains 2 hydrogen on this carbon. 2 are same. So it cannot show geometrical isomerism. So this is not the right answer. And the second one, 1-phenyl 2-butene. 1-phenyl 2-butene. I am writing 2-butene first. This is 2-butene having 1 phenyl over here. Okay. This can show. This can show. How can? See, here this group is this one and here another one. Here also the 2 groups attached are different. So the 2 group on this particular carbon are methyl and hydrogen. Both are different group. And this particular carbon are phenyl, methyl and hydrogen. There's a small mistake over here. This is not like that. Simply write it as CH2, not CH3 hyphen. Okay. So this molecule can show geometrical isomerism. Similarly, this is butane. Butane cannot show geometrical isomerism. This is 1,1-diphenyl 1-propene. That will be like this. 1-propene means this one. 1,1-diphenyl. That means here it have 2 phenyl. These 2 groups are same. So no more discussion required. Okay. So moving on to next question, that is the correct order of acidity of the following compound is. Correct order of acidity of the following compound is. Yeah, this is an interesting question from organic chemistry. We have been given different types of acids. How can we compare the acidity? See, the acid given, I am just copying the acid given, RCOOH, then C2H2, or it can be written as CH1CH, acetylene, then water, then alcohol. These are the acids given. See, carboxylic acid are strong acid in organic because, see, in each example you can see that hydrogen is attached to electronegative atom. Here it is oxygen, here it is sp carbon, here also it is present on sp oxygen, that is, this is like this only, HOH, that means oxygen with electronegativity, and here also this is oxygen. And do you know that in this case this oxygen is attached with the strong electron withdrawing group, therefore its electronegativity will be greater compared with the normal oxygen. See, in all these cases, the acidity in all the 3 cases, the first, third and last cases, acidity is due to OH bond. This oxygen being electronegative will attract the electron towards it, releasing hydrogen as H+, and this is what is called acidity, releasing tendency of hydrogen. That will be greater in the first case because in this case this group is electron withdrawing group, therefore the withdrawing power of this oxygen will be greater than other cases. And if you look here, this is also oxygen, but when compared with the last one, this is being electron donating group electron withdrawing ability of oxygen will get decreased. See, if this have an electron donating group over here, this will push its electron density. This will push its electron density towards oxygen. Consequently, the electron negativity or electron attracting ability of oxygen will be decreased. Consequently, the ability or the tendency to release H plus will get decreased. Consequently, this will have least acidity compared with these two. And when we look off here, that is carbon is sp hybridized having 3.3 electronegativity. That is less than 3.5 electronegativity of oxygen. Therefore, its acidity will be less than all these K3. When we compare all these three, this oxygen with greater than 3.5 electronegativity due to this group, withdrawing group having greater acidity. Then among these two oxygen, this oxygen doesn't have any electron withdrawing or donating group associated to it. Therefore, this will be having second. But this is actually oxygen, but it is surrounded by an electron donating group that will cause decrease in electronegativity value. So just below 3.5 will be the electronegativity of oxygen here. So greater the polarity of OH bond, greater will be the acidity. With decrease in electronegativity, polarity of the bond will be get decreased. Okay. So third position will move to here, and this is having only 3.3 will get fourth position. So the correct order of acidity is RCOH, then water, then ROH, then acetylene. Moving on. Which of the following species could be expected to exhibit aromatic character? See, for aromatic character, the molecule should be cyclic. The molecule should have planar geometry. The molecule should have complete delocalization of pi electron. The molecule should obey 4n plus 2 pi electron. 4n plus 2 pi electron. Now come to this one. Here 4n plus 2 pi electron means number of pi electron must be either 2 or 6 or 10 or 14 or 18 or 22. The difference is 4. You can remember this as number of electrons that can be accommodated in subshells. S can accommodate 2, P, D, F, G. Likewise can also remember it. See, in the first example it has been given 2 plus 2 plus 2 plus 2, that is 8 electron is given. So this is not aromatic. 2 plus 2 plus 2, 6 electron is there. So this is aromatic. 2 plus 2 plus 2, 6 electron, this is also aromatic. 2 plus 2, this is positive charge, no electron, this is 4 only. So the second and third is right answer. Where is the answer? Second and third. D is the right option. Molecules having these conditions are aromatic. So the second and third molecule obeying these conditions, so they are aromatic. Which of the following is secondary pollutant? Yeah. The pollutants which are naturally found in atmosphere are primary pollutants. The pollutants which are formed by the reaction of these primary pollutants with hydrocarbons or any other pollutants are called secondary pollutants. See, already atmosphere ഉള്ള ആൾക്കാർ അല്ലെങ്കിൽ നമ്മുടെ എർത്തിലേക്കുള്ള ആൾക്കാരാണ് primary pollutants. അവർ തമ്മിൽ react ചെയ്ത് കിട്ടുന്ന ആൾക്കാരാണ് secondary pollutants. Here this is carbon dioxide is a natural component, that is primary pollutant. N2O, SO2 ഒക്കെ primary pollutant ആണ്. PAN, peroxyacetyl nitrate ആണ് secondary pollutant, that is formed by the reaction of hydrocarbon with nitrogen oxides and ozone, etc. The other compound formed along with this are formaldehyde, acrolein. These are secondary pollutants. Instead of PAN, you can expect formaldehyde, acrolein. Okay, all are secondary pollutants. And don't get confused this PAN value with the polyacrylonitrile that you studied in the chapter polymer. Polyacrylonitrile, right? CS2CH, and this is the monomer of polyacrylonitrile called acrylonitrile, and that is differ from here. This is peroxyacetyl nitrate. Moving. If A stands for the edge length of this cubic system, simple cubic, body-centered cubic and face-centered cubic, then the ratio of radii of the spheres in this system will be respectively. See, in case of simple cubic means what? Simple cubic means very simple. Let me write here. this is simple cubic, touching the corner elements each other. So this distance is actually r, this distance is also r. So this distance is what is called as edge length. So I can say that A equals to r. Similarly for face-centered cubic. Face-centered cubic means what? Face-centered cubic means that will be having, let me draw here. Will be like this. That means corner touch but it touches the face-centered element atoms. So if I draw a triangle like this, then this is r, 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 r. This is 4r. Then from this I can write 4r equals root 2a according to Pythagoras theorem. Similarly for body-centered cubic we can write 4r equals root 3a. Now what has been asked? A equals, no, R equals, here I can write R equals, in the first case R equals 1 by 2A. Second case what has been asked here? Simple cubic, then body-centered. Body-centered is this one. This is body-centered, this is face-centered. So R equals, I can write root 3A by 4, root 3A by 4. Then for simple for FCC, bodies and face-centered, I can write R equals root 2 by 4. So 1 by 2a, root 3 by 4a, root 2 by 4a, likewise. So which is the right answer? 1 by 2a, root 3 by 4a, 1 by, this is not. So root 2 by 4 can be written as 1 by 2 root 2, right. This is the right answer. See, root 2 divided by 4. 4 I can write 2 into 2 into 2. That means 2 can also be written as root 2 by root 2 into root 2 into 2. These two root 2 will be cancelled. Then we get 2 root 2 in the lower part. That is 1 by root 2 root 2a. This is the right answer. Did you get it? Very interesting and very simple and very frequently asking question. Okay. Next, percentage of free space in a body-centered cubic unit cell is. First of all, simple cubic packing efficiency 52%. Body-centered packing efficiency 68%. Face-centered or cubic close packing, this is 74%. The remaining space, that is here 48%, here 32%, here 26% are free. In body-centered cubic it will be 32%. So B is the right answer. At 25 degrees Celsius, the molar conductance at infinite dilution for the strong electrolyte are given. And what will be the molar conductance set of weak electrode barium hydroxide? This is a direct application of Coleridge's law. It can be simply written, right? Barium hydroxide contain barium 2 plus 2 OH minus. Do this NaOH plus, NaOH plus BaCl2 minus NaCl. NaOH plus BaCl2 minus NaCl. What will get? I should write 2 NaOH. See here, 2 NaOH means these two. See, I will split up with the line, the equation and cut the mathematics. These two sodium can be cut. E and chlorine cut. So B plus 2 OH means that is E mathematical calculation barium hydroxide. I will ionize the sum of 10th class plus 1 plus ഡയറക്റ്റായിട്ട് ഈ സിമ്പിളി നമ്മൾ എങ്ങനെയാണ് ചെയ്യുക എന്നുള്ളതാണ് ചെയ്യുന്നത്. അതേപോലെ തന്നെ ഈ എക്സാമ്പിളും ഇതൊക്കെ ഫ്രീക്വൻ്റ് ആയിട്ട് നിങ്ങൾ ക്വസ്റ്റ്യൻ പേപ്പറിൽ കണ്ടുകൊണ്ടിരിക്കുന്നതാണ്. അത് എക്സ്പ്ലനേഷൻ്റെ ആവശ്യമില്ല. ഇത് ആദ്യം കാണുന്നവർക്ക് വേണ്ടി ജസ്റ്റ് പറഞ്ഞതേ ഉള്ളൂ. ഇത് പറയുമ്പോഴും ഇത് പറയണോ ടിക്കറ്റ് പോയാൽ പോരെന്ന് എനിക്ക് തോന്നിയതാണ്. ദാറ്റ് മച്ച് ഫ്രീക്വൻ്റ്ലി ആസ്കിങ് ക്വസ്റ്റ്യൻ ആണ്, പഠിച്ചു വെക്കണം. മൂവിങ് ഓൺ. സോ വാട്ട് ഐ ഡിഡ് ഹിയർ, 2 into NaOH. What is the value of NaOH? That is 248. 2 into 248 plus barium chloride value is 280 into, oh here one more is there, into 10 raised to minus 4 plus 280 into 10 raised to minus 4 minus 126 NaCl 126. 2 into 126 into 10 raised to minus 4. So 10 raised to minus 4 is common everywhere. So I can put that into outside. 2 into 248. That is 496 plus, what is this actually, 280. 280 minus 2 into 126, that is 252. Okay. So this will be close to here. The difference is 28. 496 plus 28 or 500 plus 20. 524 around is getting. Yeah. 524 into 10 raised to minus 4 is the right answer. Solve this. You will get it. The difference here, this is 28. Right? 28 plus 496 will be 524. Next question. Which of the following statement for the order of a reaction is incorrect? Order of reaction is always whole number. No. Order of reaction fraction agam, zero agam, negative agam. So this is wrong. So this is the right answer. Order can be determined only experimentally. ശരിയാണ്. Order experimentally കിട്ടുന്ന property-ആണ്. Order is not influenced by stoichiometric coefficient. ഒരു കോയിഫിഷ്യൻ്റ് എന്താണെങ്കിലും, ഇപ്പോൾ ഫോർ എക്സാമ്പിൾ decomposition of ammonia, there is something inside before NH3, but the reaction follows zero order kinetics. That means power 0 ആണ്. ഇപ്പോൾ സ്റ്റോയിഷ്യോമെട്രി എന്താണെന്നുള്ളത് കൊണ്ട് നമുക്ക് ഒരിക്കലും ഇത് തന്നെയാണ് ഓർഡർ എന്ന് പറയാൻ കഴിയില്ല. So and so on. So the right option is first one. Half-life period of a first order reaction is found to be 1386. The specific rate constant of the reaction is, see, T half equals 0.693 by K, right? So it has been asked K കാണാനാണ്. So 0.693, or you can also write it as 0.7 by 1386. Dear students, ഇപ്പോൾ ഇങ്ങനെ തരുന്ന വാല്യൂ മിക്കവാറും ഈ 0.693യുടെ ഒരു മൾട്ടിപ്ലോക്ക് ആയിട്ടായിരിക്കും തരുന്നുണ്ടാവുക ഫോർ മാത്തമാറ്റിക്കൽ സിംപ്ലിസിറ്റി. ഓക്കെ, സോ ഐ എം ഡൂയിങ് ദിസ് ലൈക്ക് ദിസ്. K equals 7 into 10 raised to minus 1, that is 0.7 divided by 13.8 into 86 into 10 raised to 2 for basic mathematics. So this is 1 by 2. 1 by 2 into 10 raised. This 2 will be moved into upper part as minus 2. Then minus 2 plus minus 2, minus 1, this is minus 3. That is 0.5 into 10 raised to minus 3 will be the answer. So the right answer is both A and C are mistyped. I'm sorry, B is the right answer. B is the right answer. That much second inverse. That is 0.6 divided by 0.123. This will be around 5, and this is the answer. Answer option C. Okay. Next question. The golden number of protective colloids A, B, C, and D are 0.5, 0.01, 0.10, and 0.005 respectively. The correct order of their protective power among them. Protective power is inversely proportional to golden number. Do you remember that? Protective power is inversely proportional to golden number. Now, which is the right answer? A is having 0.5. I'm just writing A, B, C, D. The one with the least value is D. So D will be having greater protective power. Then I think B. Then this is C, then A. A, C, B, D. C is the right answer. Okay. Next one. Direct question. Moving on. Next question. Which one of the following is not an ore of magnesium? Very simple question. First option is the right option. That is gypsum. Gypsum is an ore of calcium. Calcium sulfate. Gypsum is calcium sulfate 2H2O. Right? Dolomite is an ore of calcium and magnesium. Dolomite is CaCO3, MgCO3. This is dolomite. Then magnesite is MgCO3. Don't get confused with magnetite. Magnetite is Fe, Fe3O4. Okay. Kernelite is KCl, MgCl2 dot 6H2O. So all these have magnesium. So the first one is the right option. The basicity of pyrophosphorus acid. See, what is phosphorus acid? H3PO3. How pyrophosphorus acid is prepared? By removing water molecule between two phosphorus acid. So the double of this is actually H6P2O6. Remove water from this. H4P2O5. This is the formula of pyrophosphorus acid. H4P2O5. Then the structure will be like this. Phosphorus. And one phosphorus must be doubly bonded with oxygen. And there are total five oxygen. One here and one here. And one joined through them as bridge. There are four hydrogen. One here, one here, one here, one here. This is the structure of pyrophosphorus acid. It contains two OH group. Therefore, they are basicity 2, dibasic acid. See, what is meant by basicity of pyrophosphorus acid? How many OH group is present in the phosphorus acid? That is asking. How many OH group is present in the given acid? See, if it is phosphoric acid, then the formula is H3PO4. There, 3 oxygens are there. All the oxygens are attached as OH group. So, the basicity of phosphoric acid is 3. Here the basicity is 2 because only one OH group is there. So, the right answer is only 2 OH group is there. The right answer is 2. Which of the following ion will exhibit color in aqueous solution? Yeah. For showing color, there must be unpaired or unshared electron. I mean unpaired electron. See, in scandium 3+, there is no unpaired electron and even there is no electron in its d orbital. Lanthanum 3+ also doesn't have any electron. Lutetium also have no unpaired electron. While titanium 3+ having atomic number 22, titanium, scandium, titanium. The electronic configuration is 4s2, 3d2. When it changes to titanium 3+ means 4s0, 3d1. There is one electron in the d orbital that can exhibit, that is responsible for their color formation. So C is the right option. Now, the IUPAC name of the complex CONH3 4 times Cl2, Cl is tetramine dichlorido cobalt 3 chloride, right? Tetramine dichlorido cobalt 3. Where is answer? Tetramine dichlorido cobalt. Yes, you can use chloro or chlorido. Chlorido is the best, that is preferred usually. So tetramine dichlorido cobalt 3 chloride. Third, B is the right option. B. Okay. Direct question nomenclature, coordination nomenclature. Now an important question. The order of reactivity of the following alcohols towards concentrated HCl is. See, reactivity towards concentrated HCl means reaction involving nucleophile substitution that follows SN1 mechanism. That means this reaction is happening through formation of carbocation. So the other meaning of this question is which of the following can form stable carbocation? Among these, the carbocation formed in all cases I am writing here. The first one is FCH2 CHCH3 plus FCH2 CH2 CH plus CH3. Compare their stability and write your answer. CH plus CH3 and this is benzene, CH2 plus. Among these four, the fourth one is benzyl cation is more stable one. This is the first instability, first one. Then this is secondary alkyl, that is isopropyl group without any electron withdrawing group. And if you look the first and second example, you can see fluorine. Fluorine is electron withdrawing group. In the first case, fluorine is very close to that positive carbon, where here the fluorine is a little bit far from positive carbon. That means electron withdrawing group, as you know that the presence of electron withdrawing group will destabilizes carbocation. Here the electron withdrawing group is close to positive charged ion, that is carbon. This will decreases the stability. Okay, here the decrease in stability will be lesser when compared with the first one. So the stability order will be first, second, third, fourth. This is third, and this is fourth. The total order will be 4, 3, 2, 1. Directly given it as 4, 3, 2, 1. What is the answer? C. 4, 3, 2, 1. Next question. Chlorobenzene on reaction gives phenol. How can you convert chlorobenzene into phenol? What is chlorobenzene? This is chlorobenzene. One reaction, it changes to phenol. For this, we need to add sodium hydroxide at high temperature and pressure, followed by hydrolysis at high temperature and pressure, not usual condition. This process is called a dose process. Dose process. Okay. It is then converted to salicylaldehyde. The reaction that is used to convert phenol to salicylaldehyde is called as Raymer-Tiemann reaction. For this, chloroform and alkali is used. Chloroform and alkali followed by hydrolysis will give salicylaldehyde. So that reaction is Raymer-Tiemann reaction. So X is not Friese rearrangement, not cumene, dose and Raymer-Tiemann. C is the right option. Okay. Next one. The major product of the reaction between tertiary butyl chloride and sodium ethoxide is actually alkyl halide react with sodium alkoxide gives either, this is what is called as Williamson synthesis. But during such a preparation of either, the alkyl halide should be primary or secondary and should not be tertiary. What is wrong with tertiary? If we take tertiary, then there will be beta elimination reaction. That is actually, this is nucleophile substitution reaction. As you know, every substitution reactions are accompanying in association with the elimination reactions. എല്ലാ സബ്സ്റ്റിറ്റ്യൂഷൻ റിയാക്ഷൻ്റെ കൂടെ എലിമിനേഷൻ്റെ കൂടെ സബ്സ്റ്റിറ്റ്യൂഷൻ നടക്കുന്നുണ്ട്. മെജോറിറ്റി ആരാണോ ഉണ്ടാകുന്നത് അതിൻ്റെ അടിസ്ഥാനത്തിലാണ് നമ്മൾ നെയിം ചെയ്യുന്നത്. വൈ, എന്തുകൊണ്ടാണ് അങ്ങനെ നടക്കുന്നത്? ബിക്കോസ് ന്യൂക്ലിയോഫൈൽസ് ആർ bases as well. Certain cases, basic character will be increased. In presence of base, elimination will occur. Base means H plus acceptor. Nucleophile means carbon like പോകുന്ന ആള്. So in this case, that means if the alkyl halide is tertiary, that is tertiary butyl bromide, that will be like this: CH3 CCH3Br. When this treated with the NaOR, what happens? This is being a strong base. This will undergo beta elimination reaction, giving isobutylene or this one, isobutylene. This will be obtained. So the name is 2-methyl-propo-1-ene. 2-methyl-propo-1-ene. A is the answer. Remember, normal alkyl halide reacts with the sodium alkoxide, gives either by SN2 mechanism, while tertiary alkyl halide gives alkene by beta elimination mechanism. Moving on. Pentan 3-1 is not obtained from 2,2-dichloropentane. See, 2,2-dichloropentane means CH3, CCl, CH2, CH2, CH3. This is 2,2-dichloropentane. On hydrolysis, this chlorine will get substituted by OH, and 2 OH cannot be on same carbon, that will be changed into ketone. I am writing that unstable product in the first step. CH2, CH2, CH3. Now water molecule will be removed here from H2O, and finally that change into CH3, CO, CH2, CH2, CH3. So it results pentan 2-on. Yeah, this is pentan 2-on, not 3-on. So this is the right answer. Yeah, do the same here. 3,3-dichloro. Instead of here, if it were here, then you will get 3 on. So that can give. Pendant 3 on oxidation gives pendant 3 on. Pendant 2 and pendant 2 ion. Next option is pendant 2 ion. I am detailing all examples. CH2C triple bond CH. This on acidic hydration using dilute sulfuric acid and mercuric sulfate will give a product that can be easily understood by this way. That is CH3, CH2, CH2, CO, CH3. That means this molecule can also give pendant 2 ion. Very sorry, I wrote here pendant 1 ion. If this is pendant 2 ion, this will be like this. CH2C triple bond CCH3. You need to add water molecule like this. Right? There it can form as CH3, CH2, CO, CH2, CH3. Remember here one additional point to say. Here there is a possibility of addition like this as well. So you can get the product like this also. That is CH3, CH2, CH2, CO, CH3. And do you know, among these, the second one is the major one. But as per the question, it can give this product. But remember, this is the major product because methyl ketone is more stable. Okay. So pendant 2 ion can give 2,3 on. Pendant 3 ol can give 3 on. 3,3-dichloropendene can also give 3 on. But 2,2-dichloropendene cannot give 3 on but give only 2 on. So that is the answer of this question. Moving on. In aqueous solution, the basic strength of amines decreases in the order. See, the given are methylamines, all these cases methylamines are given. Among methylamine, the basicity order is secondary, primary, tertiary. And among ethylamine, the basicity order is secondary, tertiary, primary. See, smaller amine have smaller digit. If you count this as 213, that is 213. This is 231. Which is the smallest one? 213. And that is the smallest amine. That means you can remember like this. Smallest amine, methylamine. Adinte number 213 എന്ന് ഓർക്കാം. ഇത് ethylamine 231. ഞാൻ പറഞ്ഞു വരുന്നത് രണ്ടും സെക്കൻഡറിയിലാണ് തുടങ്ങുന്നത് എന്ന് നമുക്ക് ഓർമ്മയിൽ ഉണ്ടാകും. പിന്നീട് ആർക്കാണ് മീൻസ് പ്രൈമറി ആണോ ടെർഷ്യറി ആണോ എന്നാണ് കൺഫ്യൂഷൻ വരിക. അപ്പോൾ രണ്ടും സെക്കൻഡറിയിൽ തുടങ്ങിക്കഴിഞ്ഞാൽ പിന്നെ ഒന്നിൽ 1,3 മറ്റൊന്നിൽ 3,1. അപ്പോൾ ആ സെറ്റ് ഓഫ് നമ്പേഴ്സ് ഓർത്താൽ 213, 231. അതിൽ ചെറുതാരാ മീഥൈലമീൻ 213. മീഥൈലമീൻ ചെറുത്, അപ്പോൾ 213 ചെറുത്. അപ്പോൾ അത് കീപ്പ് ഇൻ മൈൻഡ്. ദെൻ യു ക്യാൻ സോൾവ് ദിസ്. 213 ദിസ് ഇസ് 1 നോ 2 3 ഇതുമല്ല 3 അല്ല 2 1 2 1. Actually this is thrice n. There is a typing error. Thrice n is there. So this is the right answer. Which one of the following statement is incorrect for the sucrose? Which one of the following statement is incorrect for sucrose? It is obtained from cane sugar. ശരിയാണ്. It is not reducing sugar. ശരിയാണ്. On hydrolysis it gives equal quantities of D-glucose and D-fructose. അതും ശരിയാണ്. It gives aspartame when it is heated. No. So this is wrong. Therefore this is the right answer. Glyptal polymer is obtained from glycol and by reacting with it. It is given in this glycol, talic acid. No worries. Moving on. Nylon 6,6 is obtained by adipic acid and hexamethylene diamine. Board exam question. Simple question. No more explanation is required. So next question is empirical formula of a compound non-electrolyte is CH2O. A solution containing 3 gram of this compound exerts same osmotic pressure as that of 0.05 molar glucose solution. What is the molecular formula of the compound? Yeah, we have a compound having empirical formula CH2O, and that solution have same osmotic pressure as that of 0.05 molar glucose. By keeping this knowledge, how can we find out the molar formula, that is molecular formula of that particular compound? So being them equal osmotic pressure, I can write pi equals pi glucose. Pi of this compound equal pi of glucose. That is concentration are same. I can write W by M equals W by M of glucose. Substitute here. W is given as 3 gram. So 3 by, we want to find out molar mass. From molar mass, molecular formula can be obtained if we know the empirical mass formula. Right. See, what is molecular formula from empirical formula? N into empirical formula. What is N? N equals molecular mass divided by empirical formula mass. From here, the empirical formula mass is very clear. That is 1 carbon 12 plus 2 plus 16. This is 30. Now find out N value. That is something by 30 will be the M value. From that, here we can substitute here. Then we can get the correct answer. For that, we need for molecular mass. For finding out molecular mass, we want to find out this M value. That is the molecular mass of this compound. Equals W by M. M means glucose 180 analog. W, what is W for glucose? W equals N into molar mass. Right. This is 0.05 molar solution. 0.05 molar 1 liter solution will have 0.05 mole in it. So I can say that 0.05 into molar mass is 180. So this will be 9 gram, I think. Yes, 9 gram. 9 gram. Yeah. So this is 9. From here, we can calculate the value of M as M equals 3 into 180 divided by 9. So by substituting this, you will get it as 60. Molar mass is 60. Direct calculation, very simple. Direct calculation. Molar mass is 60. So for finding out molecular formula, N into EF. N is calculated by 60 by 30. This is 2. Now do this. Molecular formula equals 2 into empirical formula, that is CH2O. The formula is C2H4O2, and this is the right answer, B. Okay, moving on. The average oxygen state of sulfur in Na2S4O6. Na2, sodium will have +1 oxygen state, so 2 plus 4 into X plus 6 into -2. That is X equals, simplify 2, 4x equals 12 will be outside, 12 minus 2, that is 10, or X equals 10 by 4, that is 2.5. A. I got it. Did you? The order of acidic strength of boron trihalide is, the acidic strength of boron trihalide increases down the group, therefore the right option is first one. Yes, the next question is, cetyl trimethyl ammonium bromide is popular as, they are cationic detergents. Cetyl trimethyl ammonium are cationic detergents. They are used as germicide. Then, yes, our 44th question, which of the following law directly explains the law of conservation of mass? Law of conservation of mass means what? Mass can either be created nor be destroyed. That is based on Dalton's law. Atoms can either be created nor be destroyed, right? From there, we can conclude law of conservation of mass as well. Moving on. 0.2 molar aqueous solution of barium hydroxide is found to be 90% ionized. And what is the pH of the solution? It is not an easy question, little bit complicated. Don't worry how to solve this. See here, we have barium hydroxide. This one undergoing ionization, Ba2++, 2OH minus. The initial molar concentration is C, here 0 before ionization. At equilibrium concentration, this is diluted to, that is 1 minus alpha. Here I can write is a C alpha and a 2C alpha. Now from here we can get the concentration of OH minus. From the concentration of OH minus we can calculate pH. That's all. Right. How can we calculate the concentration of OH minus? Concentration of OH minus equals 2C alpha, isn't it? Or 2 into concentration of the solution is given as 0.2 into percentage dissociation is 90. So I can write it as 90 by 100. 90 by 100. So this will be 1.18 and 2, that is 0.36. This is 0.36. 0.36, or I can write as 36 into 10 raised to minus 2. I can write it like this, or 3.6 into 10 raised to minus 1. 3.6 into 10 raised to minus 1. This is the concentration of OH minus. From this value, we can calculate POH, and from POH you can calculate pH. Come on. POH equals negative logarithm of OH minus ion concentration. So negative log, the value is 3.6 into 10 raised to minus 1. 3.6 into 10 raised to minus 1, or this is in the form of log AB. Log AB equals log A plus log B. So I am taking minus outside. So log 3.6 plus log 10 raised to minus 1. Log 10, these are the base 10. In this log we are taking base 10. So the log 10 raised to minus 1 means simply minus 1. So this is minus of log 3.6 minus 1. What is log 3.6? Do you know the value of log? 1 equals 0, 2 equals 0.3, 3 equals 0.477, 4 equals 0.6, 5 equals 0.7, 6 equals 0.8, 7 equals 0.855, and 8.85. Just 85 is sufficient. Then 0.9, 9 equals 0.95, log 10 equals 1. And this is not exactly 0.88, this is also 0.77. That is rounded to 0.8. See, log 3 is 0.477, log 4 is 0.6. Then the value of 3.6 will be around 0.55 something, 0.5 something. So I am write it as 0.5 something, right? 0.5 something minus 1. So by substituting, this will be equals equals 0.45 around, right? 1 minus 0.55 will be around 0.45. Okay, this is the value of POH. Actually, we need to find out pH. Now, value of POH is found that 0.45. And we have already studied that pH plus POH equals 14. Or pH equals 14 minus POH. 14 minus 0.45 will be around 13.5 something, 55 will be, which is close to this value. The value of pH will be 13 point something. Let me check the value which is close to this answer. Yeah, here is 13.56. This is the right answer. So let me once again do solving this question. First of all, we are finding out the concentration of OH minus in this solution, because this is a hydroxide group is present in barium hydroxide. Therefore, concentration, while writing it, I should write here 2 OH minus. That means 2 molecules of OH, number of ion OH minus are released from 1 molecule of barium hydroxide. So from that we can write concentration of OH minus equal to C alpha, where we get this value. Finding the POH of that, we get 0.45. And from the knowledge that pH plus POH equals 14, we can get value of pH as 14 minus POH. That is the right answer. So moving next question. The lower electron affinity of fluorine than chlorine is due to. First option is correct. Smaller size of fluorine, not smaller nuclear charge, not all this. Smaller size. As you know that in case of fluorine and in case of chlorine, the difference is atomic size. In case of fluorine, already 7 electrons are present in the outer shell. So the incoming electron will feel repulsion due to its smaller size, because already 7 electrons are present on the smaller shell. So smaller size is responsible for lesser electron affinity. Now the maximum oxidation state of actinide is, okay, actinide can show up to +7 oxidation state. Okay, neptunium, plutonium, etc. shows +7. Uranium, neptunium, plutonium, americium shows +6. And their common oxidation state is actually +3, but +7 is shown by neptunium and plutonium. Therefore, answer is B. Moving on. The radioactive isotope of hydrogen is nothing to discuss. At CMC, the surface surfactants molecule get associates. Okay. So the last question is statement 1. Cubic system have 4 possible type of unit cell. Cubic system 4 illello 3 alle ullu. Simple cubic, face centered cubic, body centered cubic. Only 3 are possible. So statement 1 is wrong. Among the option, 3 of them starting with the wrong. So we cannot directly write the answer. Then second statement is H2O is diamagnetic substance and it is weakly attracted in magnetic field. H2O is diamagnetic, it is right, but it is not weakly attracted by magnetic field. That statement is wrong. And the last one is graphite is a covalent solid with van der Waals force as well. That is right. Everywhere van der Waals forces are there. So statement 3 is also right one. So the correct option is first and second are wrong and the third one is right one. So A is the right option. I hope you all returned the exam very well.